Let's talk now about solving linear equations a little more generally. We've seen that with the addition, the subtraction, the multiplication, and the division principles of equality, we can solve simple linear equations. It turns out that we can actually solve much more complicated linear equations using those same principles, as long as we're okay with using the principles together, using more than one at a time. So here, there's no new principles to learn. There's no new vocabulary, no new technique to learn. It's just a matter of seeing how we can put those all together. So let's begin with something still reasonably simple, because we're using just nice whole numbers and not much else. Let's say you have 2x plus 7 is equal to 15. Okay? Now, here we have an equation, a linear equation of one variable, and we want to solve by isolating the variable x. Now here you notice there's more than just one operation that's involving the x. Here it's being multiplied by 2, but you're also adding 7. Okay, so we want to eventually get rid of both of these so that we can isolate our variable x. That's what we're trying to do. We're trying to solve here. Okay, so how do we do that? Well, we need to get rid of addition and multiplication. Okay, so which one should we do first? Does it matter? It turns out that as long as you're careful, it doesn't really matter, but following a particular order will make things far simpler most of the time. What order is that? Well, it's the same order we always do things in. Parentheses, exponents, multiplication, division from left to right, and then addition, subtraction from left to right. All right? Now, this is the way we normally put together an expression. This is the way we normally simplify an expression. But notice that's not what we're trying to do here. We're not trying to put this together. We're not trying to multiply 2 times x and add 7. We're trying to undo it. We're trying to get rid of these, not put them together. So if this is the way we normally put things together, how do we take them apart? We're going to go backwards. We're going to start off by doing addition, subtraction from left to right. Then we're going to move on to doing the multiplication, division. And then we're going to look at exponents and finally parentheses like this. Okay, so here what we're going to do is we're going to, this is how you put things together. This is the order of operations. But if you want to take things apart, if you want to get this piece and move everything else away, we're going to take this order of operations backwards. We're going to take things apart. Okay. So let's take a look. Normally, the very last thing I would do is I would do addition and subtraction. But even though that's the last thing I would normally do to put things together, to take them apart, that's the first thing I want to undo. So let me get rid of that plus 7, and I'm going to do that by subtracting 7. That way 7 minus 7 is 0, and that goes away. Now, whatever I do to one side of an equation, I do the same thing on the other side, so I'm going to subtract 7 there as well. And this will give me 2x equals to 15 minus 7 will give us 8. Now, to isolate my x, what I want to do is I want to get rid of this 2. Notice these are being multiplied together. All right, we did all the addition subtraction that we could. Now we're going to go ahead and move on to the multiplication division. Here, we want to get rid of this multiplication. Notice this is being multiplied 2 times x. And the way you get rid of your multiplication is we're going to go ahead and divide by it. That way, 2 divides 2, and that gives me 1, which is what I want. I want 1x. On this other side, I'm going to have 8 divided by 2 is 4. And this is my solution. Now remember, whenever we have a solution to an equation, whenever we solve an equation, we find the solution. That means that if you take this number and substitute it back in, it should give you a true equation. So if you are not sure, you can always double check by plugging that back in. 2 times 4 is 8, plus 7 is 15. So sure enough, that actually does work out. Go ahead and give that a try. Same kind of problem. Let's say you have 3x minus, let's say 16 equals 20. Go ahead and pause the video and work through this. Remember, you're going to follow this backwards. You're going to follow the order of operations backwards. You're going to do addition, subtraction, then multiplication, division here. Once you are done, go ahead and unpause the video and we'll go through and confirm it together. All right, so the first thing we want to do is we want to get rid of this negative 16. We want to get rid of all addition subtraction first. To get rid of a minus 16, let me go ahead and add 16. That way 16 and minus 16 together give me 0. All right, well that's 0, which means the only thing left on this side of the equal sign is our 3x. On this side, 20 plus 16 is 36. And now we want to go ahead and get rid of that 3. Since that's being multiplied, we want to go ahead and divide. To get rid of addition, we use subtraction. To get rid of subtraction, we use addition. Here, to get rid of multiplication, we use division. To get rid of division, we use multiplication. Here, 3 divides 3 to give us 1, which is what we want. We want 1x. Over here, 36 divided by 3 is 12. And that is our solution. Again, you can always check. 3 times 12 is 36. 36 minus 16 is 20. Yeah, that works out just fine. Now you'll note that here we deal with multiplication, division, addition, subtraction in the opposite order that we usually do. What about exponents and parentheses? I guess we do those at the end, right? Well, hypothetically, yes, we would. But oftentimes, especially with linear equations, it's going to be far simpler if we simplify those away first. You say, what do you mean? Well, let's consider, for example, something that looks like this. Let's say I have 2 times 3x minus 9 plus 4 is equal to 20. Okay? Now, notice I have some parentheses here. One thing I could do is I could do exactly what we have here. We could say, okay, let's get rid of the addition subtraction first. So let me subtract the 4 away. And then let me deal with multiplication division. Here that 2 is being multiplied into those parentheses. So let me go ahead and divide that 2 away. And then finally, there's no exponent here, so I would jump to parentheses. And I would say, okay, now simplify this out. And that would work. That would get us the correct answer. However, as these expressions get even bigger, doing this and sticking to it exactly the way it's written is sometimes going to be longer than it needs to be. You say, okay, well, if that's longer than it needs to be, what is the shorter way to do it? What we want to do is we want to begin by simplifying our expression on either side of the equal sign before we start solving. Now, obviously, some equations have one or both sides that cannot be simplified. For example, here, that's as simple as it's going to get. And same thing with this one. In this equation, this right side, when we say right side, we mean to the right of the equal sign. The right side is already as simple as it's going to get. It's just a single number. But on the left side, I notice that I have multiplication of a number times an expression. Here, I could distribute. I could use the distributive property. And that way, there wouldn't be any parentheses to begin with. So I wouldn't have to worry about getting rid of them because they wouldn't be there anymore. Generally, what we want to do is we want to simplify our equations down as much as we can using the distributive property, the associative property, the commutative property, and by combining any like terms. Once we've simplified everything, then we go ahead and take things apart. And usually by then, all that's left is some addition, subtraction, and some multiplication, division. Okay, so let's see what that looks like. Let me go ahead and simplify. I'm going to multiply and I'm going to add. Okay, so here I am not trying to take anything apart. I'm putting it together. I'm actually trying to simplify this down. When you simplify, you're putting it together. You're trying to combine everything to smaller expressions. When you're trying to get rid of stuff, that's when you're trying to take it apart. Okay, so here we're simplifying. So we're following the normal order of operations. We're going to multiply first and then do the addition. Okay, so distribute your 2. It's going to be 6x. Distribute your 2. It's going to be minus 18. And here, this is not inside the parentheses, so it's not going to be multiplied by 2. You're just going to have an extra plus 4. Okay. Now, you notice you have some like terms here. Negative 18 plus 4 is going to be negative 14. But notice that once you simplified, what you're left with is something that looks just like the problems we've been doing. So the simplification brings it down to something where addition, subtraction, and multiplication, division will be enough. You don't really have to worry about these. So let's continue on with this problem here. We want to isolate our x. So now we're taking things apart. Now we're trying to get rid of stuff. We're trying to take these apart and move them away. So we're going to take addition subtraction first. Get rid of that first. And then finally the multiplication division. Okay. So we go ahead and add 14 to both sides. That way 14 and minus 14 goes away. It's 0. Leaves me just 6x. On this side, 20 plus 14. It's going to give me 34, like that. And finally, we can go ahead and divide both sides by this 6. There and there. This gives us x by itself. We've isolated our variable. Here, you notice this doesn't divide evenly, but that's okay. Sometimes our answer will be a fraction. Here, we can at least reduce it. Let's see, 34 is, let's see here. That'll be 2 and 17. 6 is 2 times 3. And so the only thing that simplifies here are the 2's. 2 divides 2 to give me 1. So in the end, my answer is 17 over 3. That is my solution. And we can even check it. We substitute that in all the way at the beginning. 17 thirds times 3. Well, let's see. Let's go ahead and do that off to the side here. 2 times 3 times 17 thirds minus 9 plus 4. That's supposed to equal to 20. Let's see what it does equal to. All right. In the parentheses, we're going to multiply these. You notice that just means the 3's divide away. So that's just the number 17. Let's see. It's still in parentheses. These subtract away. 17 minus 9. That's going to give us 8. And now multiply. 2 times 8 is 16. And finally, your addition, 16 plus 4 is 20. So yeah, that does give us the 20 we expected. So plugging in 17 thirds in for that x, we substitute, we simplify, and that does give us 20 the way it's supposed to. So yes, this is the correct solution. All right, so give that a try. Let's have 3 times 4x plus 5 minus 6. You can tell I work really hard to come up with examples, right? 3, 4, 5, 6 is equal to negative 15. All right, so go ahead and pause the video and give that a try. Once you have your solution, go ahead and unpause the video and we go back and confirm it together. All right, so let's take a look. Before we start solving, let's simplify. Here we have distribution and then combining of like terms. So 3 times 4x would give us 12x. And then 3 times 5 would give us 15. But now, combining your like terms, 15 minus 6, that'll give us 9. And keep the sign of the number with the greatest absolute value, so that's going to stay positive 9. Okay. Now, we've simplified. Now we start solving. And when we solve, we're going to take the order of operation backwards. We're first going to get rid of any addition or subtraction. Let's subtract 9 from both sides. This will give us 12x. This is now gone, and that's equal to negative 24. Negative 15 minus 9. Add the two numbers together to give us 24. And since they're both negative, you keep the negative there. Finally, we go ahead and divide both sides by 12. 12 divides 12 to give us the number 1, which is what we want. We want 1x is equal to, here a negative divided by a positive stays negative. 24 divided by 12 is the number 2. So again, you can tell I work very hard to come up with examples. All right? 2, 3, 4, 5, 6. Now, for our next example, you'll see that there are times when the equations have more than one instance of the variable, meaning you only have one variable, x, but it appears multiple times. So, for example, let's say that we're going to solve the equation 5x minus 8 equals 3x plus 20. Okay? Now here, this is still a linear equation, okay? But you notice that your variable appears on both sides of the equal sign. If they were on the same side of the equal sign, they'd be like terms and you could combine them. But here, these are not like terms. Why? Because like terms are in a single expression. Remember, an equation is made up of two expressions that are set equal to each other. So this is one expression. There are no like terms there. This is a different expression, and there are no like terms there. If the 3x and the 5x were both on the same side of the equal sign, then they'd be part of the same expression, so you could combine them. But that's not what we have here. Okay, so what do? Well, we want them to be on the same side. Fortunately, we can move things around using our properties. Here, I can subtract 3x from both sides of my equation. Remember, I can add or subtract anything I like, as long as whatever I do on one side, I do on the other side. By subtracting 3x, though, you'll notice that 3x minus itself is 0. Notice, we still don't know what x is, but that doesn't matter. Anytime you take a number minus itself, you're going to get 0. Right? That was the inverse property. After all, these are opposites. One is positive, one is negative, but they have the same absolute value. And whenever you add opposites, you get 0. That's the inverse property of addition and subtraction. All right, so that's going to go away. But whatever I do to one side, I do on the other side. Hey, but now, since both of these are on the same side, that means they're part of the same expression, now I can combine them. Okay, so let's combine them. 5x and minus 3x will give me 2x. 5 minus 3. And now, that looks just like the problems we've been doing. So let's go ahead and add our 8 to both sides. We're trying to solve, we're trying to isolate our x, which means we want to get rid of these terms first. We want to get rid of addition subtraction first. We get 2x equals to 28. And finally, we can get rid of this last operation by dividing both sides by 2. If I divide by 2, 2 divides 2 to give me 1, which is what I want. I want 1x equals 28 divided by 2 is 14. Just like that. Okay. Here, it doesn't actually matter which side you subtract from. It's my personal habit that I always subtract the one that's smaller. Between these two numbers, this one's smaller. I just consider that easier to work with. But that is not a requirement. If you want, you could subtract 5x from both sides, and that would be just as fine, just as good. You would get the same answer at the end. Right? So it doesn't matter which side you subtract, but you do need to get rid of one side. That way you can put all your like terms on the other side and then combine. So give that a try. Solve 7x minus 12 equals to 4x plus 30. Okay, go ahead and pause the video, give that a try, and once you have your solution, come back and we will confirm it together. All right, so let's take a look. You have a variable on both sides of the equal sign. They're not like terms, but we can take care of that by subtracting 4x on both sides. You could have also subtracted 7x on both sides, and as long as you do everything correctly, you're still going to get the same answer I'm going to get. But again, my habit is I always pick on the smaller one, so I'm going to go ahead and continue with that. 4x minus 4x is gone. That's 0. Leaves me just that 30. On this side, these are now like terms because they're on the same side in the same expression, so now I can combine them. 7x minus 4x is going to give me 3x minus my 12. And now this is Nice equation to solve. I want to get rid of my addition subtraction first. Let me go ahead and add 12 to both sides. That way 12 and minus 12 give me 0, leaving me just my 3x. And here 12 plus 30 will give me 42. And finally, to get rid of that 3, which is being multiplied times that x, I can divide both sides by 3. That x is now by itself. It's been isolated because this is 1. So that's 1x. And on this side, 42 divided by 3, oh, that'll give us what, 14? 14. And that is our solution. Oh, that's a coincidence. It's the same number. That was purely by accident. There we go. Now, a moment ago, we saw some equations where you first had to simplify before you solved. Now, here we see some where you have to get your expressions together on one side, your like terms together on one side. Well, now let's take a look at what happens if both of those happen at the same time. None of these things have to happen on their own. So, for our next example, let's solve the equation 3 times 2x minus 8 plus 4 is equal to 9 minus, let's say, 4 times x minus 6. Okay. Note that you have x's on both sides of your equation, just like you do over here. But also note that you have parentheses, multiplication, addition. You have more operations than you usually do. So here, what we want to do is we want to simplify and combine our like terms by moving one of the variable terms to the other side. Now, which way do we want to do that? Generally, you want to simplify first. Simplifying first will make it easier to add and subtract your terms away. All right, so let's start by simplifying. Here I have distribution and like terms to combine. Well, just like with any order of operations, the multiplication, in this case the distribution, would go first. 3 times 2x, that's going to give us 6x. And 3 times negative 8 is negative 24. Plus an extra 4 right there. Combining these like terms, you have a negative and a positive. They're going to be subtracted. That's going to give you 20. But then keep the sign of the number with a greater absolute value. So you get negative 20. Right there. On the other side, you're first going to distribute. Now remember, this negative is part of the 4. So when you distribute the negative along with the 4. So your 9 is not going to be part of this. But negative 4 times x is negative 4x. Negative 4 times negative 6. A negative times a negative is a positive. 4 times 6 is 24. And now you can combine your like terms. Here, these are like terms. The minus 4x is going to stay as it is. 24 plus 9 is going to give us 33. Just like that. So now, once it's simplified, now it looks a lot like this problem that we had just finished doing. We want to go ahead and isolate our variable. Okay, but there's a variable on each side. So what we want to do is we want to get rid of one of them. Doesn't matter which one. Let's pick on the smaller one. Here, 4x minus 4x, that's 0. That's going to go away, leaving you just your 33. Over here, 4x plus 6x is going to give us 10x minus our 20. And now we have a nice equation to solve. We want to go ahead and isolate our variable, and we're going to do that first by getting rid of addition and subtraction, and then finally dividing this out. Okay. So let me go ahead and add my 20. That way this 20 minus that 20 becomes 0. Whatever I do on one side, I do on the other side. So that's going to give me 10x. That's gone. 33 plus 20 is 53. And finally, we can go ahead and divide both sides by our 10. That way 10 divided by 10 is 1, which is what we want. We want 1x. And over here, dividing both sides by 10, you can write that as a decimal if you like, 5.3. or a fraction is perfectly fine here. This doesn't reduce, so you can just leave it as 53 over 10. If your equation had started off with decimals, you would put it as decimals. If your equation started off with fractions, you put it as fractions. You always put it in whatever kind of coefficients you started off with. But in this case, you started off with all whole numbers, so there's nothing that tells you what answer you're supposed to write. There's nothing that tells you what form your answer is supposed to be written in. So here you can just choose. Personally, I think this is just, I'm already done. I don't need to convert this to a decimal. So that is my solution. So note, first we simplify both sides, distribute and combine. Then we get rid of the variable from one side, doesn't matter which one, as long as we have the variable all together on one side. And then we isolate the variable, get rid of addition, subtraction, then multiplication, division to get our result. All right, so give this a try. Let's have you try -3 plus 5 times 4x minus 2 is equal to 3 minus 4 times 2x plus 7. Okay. Go ahead and pause the video, solve that equation. Solve. And once you are done, go ahead and unpause and we'll confirm that together. All right, so first of all, we're trying to simplify each side. We have like terms to combine and we have distribution to do. So let's do our distribution first. 5 times 4x, that'll give us 20x, and 5 times -2 is -10. We've distributed our 5. And now combining your like terms, you have -3 minus another 10 is -13. You're adding two negatives, so you're going to add the numbers and keep the negative. We'll do the same thing on the other side. Here we're going to distribute. Remember, the minus is part of the number. When you distribute, negatives are part of the number that gets distributed. So here that's going to be 3. Minus 4 times 2x is minus 8x. Minus 4 times 7 is minus 28. And then these are like terms. You're adding a positive and a negative, so that's going to be subtraction. 28 minus 3 is 25, while you keep the sign of the greater number. Of the number with greater absolute value, rather. So, minus 25. Okay, so now this side is as simplified as we can make it. Same thing with this side. So now what we want to do is we want to get rid of one of these. And I'm going to go ahead and pick on this one. Let me add 8x to both sides. And here we combine those, and here we combine those. By adding 8x, that's going to make this minus 8x go to 0. So what we want that to go away. We don't want any variables on this side. It's going to leave us just our minus 25. Adding 8x on this side gives us two like terms that we can combine. So 28x minus 13 is equal to negative 25. And now we're down to a nice simple equation to solve. Simple, relatively speaking, compared to what we have above. So if we now add 13, that gets rid of our minus 13. 13 minus 13 is 0, which is what we want. We want that to go away. So we get just 28x equals to a negative plus a positive. Those are being subtracted. That gives us 12. But then we keep the sign of the number with greater absolute value. So negative 12. And finally, we want to divide both sides by 28. That way, 28 divides 28 to give us 1. All right, that's 1x. That's what I want. I want 1x by itself. On this side, I can reduce this. After all, that's 12 is 2 times 2 times 3. 2 times 2 is 4 times 3 is 12. 28 is going to be 2 times 2 times 7. 2 times 2 is 4. 4 times 7 is 28. Still have my minus there. There's no reason for that to go away. And now you notice that these 2's divide out. 2 divided by 2 is the number 1. 2 divided by 2 is the number 1. So right here, that's 1 times 3 is 3. Don't forget your negative. On the bottom, 1 times 7 is going to be 7. So in the end, we have x equals negative 3 over 7, negative 3/7 as our solution. Now, up to now, you've noted that linear equations all seem to have just one solution. Maybe the solution is positive or negative, fraction, whole number, decimal, but we seem to only have one. That's usually going to be the case. Most linear equations are going to have a single solution. Those are called conditional equations. Conditional linear equations are equations which have only one solution. Now, this can be generalized to other equations. Now, not every equation will only have one solution, but every equation, or most equations, will have a set number of solutions. Oh, this equation has one solution, this equation has 2, this equation has 5, or whatever. Those are called conditional equations. In other words, they're true on the condition that we're using this number. Conditional equations. Those are equations with some real numbers. Let's write it this way: some, but not all, real numbers as solutions. Meaning, if I give you an equation, you could find some solutions. Maybe 1, maybe 2, maybe 5, maybe 50. But you could find some. But it wouldn't be every number. It's not like every number is going to work. You have to find specific ones. And again, maybe you're finding a specific 1 or a specific 2 or a specific 50. But a conditional equation is an equation which has some, but not all real numbers as solutions. Okay? This is what you'll usually have for equations. And in particular with linear equations, when you say some, really we mean 1. But there are 2 other kinds of equations. Again, most equations are conditional. Some real numbers are solutions, but some are not. Contradictions, those are equations that have no solutions. We'll see an example of that here in a moment, but they're not very common compared to conditional equations. Most of our equations will have at least some solutions, but if it has no solution, that's called a contradiction. Finally, the third category is what's called an identity. An identity is an equation where every number is a solution. Not just a select few or a select 1 or a select 5 or whatever, but any and every number you could ever imagine. 1 is a solution, so is 2, 3, 4, 5, 1/2, 1/3, 1/8, everything. Every number is a solution. Identities are equations with every real number as a solution. Okay, so what do those look like? All right, well, let's take a look at some examples of those. Now, we've seen lots of examples of conditional equations. In fact, every equation we've seen so far has been conditional. You've had, in this case, in our cases, we've had one solution, and other solutions just don't work, right? Other numbers just don't work as solutions, I mean. Here you could say x is equal to 9. In fact, you could take a minute and try it if you wanted, and you'd find that both sides are not equal. So yeah, we do have some solutions, in fact, one solution, but other numbers don't work. Okay, but now let's take a look at an example of one of these other kinds of equations. Consider 3 times 2x minus 5 equals 4 times x minus 8 plus 2x. Okay. So far this doesn't really look like anything different. It looks like the equations we've been doing. You won't know ahead of time whether you have a conditional equation, a contradiction, or an identity. You're just going to have to work through it, and at the end, we'll find which of these it is, which is nice. You don't have to know ahead of time what's going to happen. Just assume that every equation is going to have an answer, and if it's something different than just the typical conditional equation, then the work that you're doing to try to find those solutions will tell you that that's the situation you're in. So let's see what that's going to look like. Without knowing that this is anything different, we would just proceed to solve. We would start by simplifying both sides of our equation. We would distribute. Okay, here we go. Here's some distribution. 3 times 2x is 6x. 3 times minus 5 is minus 15. And then combine like terms, which here there are no like terms, so we'll just leave it alone. Okay. Now over here, we're going to distribute. 4 times x is 4x. And 4 times negative 8 is negative 32. Oh, and then you have an extra plus 2x, which was not part of that distribution. But now we do have some like terms. Over here we didn't, but here we do. Okay, so let's combine our like terms. Here, let me just bring that down. 6x minus 15. Here, when I combine my like terms, I have 6x plus, I have 4x plus 2x, which is 6x. And then my minus 32 is not like those, so that'll stay separate. Okay. Now, once I have simplified both sides of my equation, I'm going to do what I've been doing, and that is I need to get rid of the variable from one side of that equation. So here I'm going to go ahead and get rid of that one, right? Same thing over here. I have a variable on either side of my equation, so I'm going to get rid of one of these. Let me subtract 6x from both sides. That way, 6x minus 6x is 0, and that's gone. So notice right here, all that's left is that negative 32. Okay. Over here, now all of our x's are together, so we can combine them as like terms. But you notice that 6x minus 6x is 0, so that variable's gone too. And what's left is a minus 15. Notice that all of your variables are gone. It's when the variable disappears, that's when you're going to have one of these other cases, either a contradiction or an identity. Because x represents your solution. Okay? Without an x, we're not going to have a regular solution. We're not going to have a conditional equation. It's got to be one of these other ones. Okay, so which one is it? Well, it depends what's left once your variables disappear. So if your variable disappears, you're not going to have a conditional equation. It's going to be one of these two. Okay, so which one is it? If your variables all disappear and you're left with just numbers, what you want to ask yourself is, this equation, is it true or is it false? Well, obviously this is false. Negative 15 is not equal to negative 32. When you have all of your variables disappear and you're left with a false statement, that's a contradiction. That's a contradiction. Because what you're saying is, I want to find what number or numbers I could plug in to my equation so that I would get a true statement. Well, notice it doesn't matter what variables I plug in. It doesn't matter if I say x is 1 or x is 5 or x is negative 6 or anything else, because there is no x. And the only equation is already false. It can never be made true, which means it doesn't matter what I plug in for x, I'm going to get a false statement, always, which means that, well, there is no number that gives me a true statement, which means there's no solution. So that's a contradiction. Whenever you have something like this, you got rid of all your variables and you're left with a false statement. That's called a contradiction. In the end, since you're looking to solve the equation, this equation has no solution. Just to clarify, when we say that there's no solution, that doesn't mean we can't find one. That doesn't mean we don't know what it is. That means there isn't one. There is no number, positive, negative, fraction, whole number, decimal, or otherwise, which, if you substitute into these variables, will make this equation true. This equation can never be true for any number. So that's what we mean when we say no solution. And when you have an equation that has no solution, it's called a contradiction. Okay? Another example. Let's say we have four times 3x minus 5 plus 1 equals 5 times 2x times negative 6, like that, plus 2x plus 11. All right, so same thing. The equation starts off looking like any other linear equation. We don't know ahead of time that it's going to be something strange, if at all. So we just proceed to try to solve. Here we can simplify. We can begin by distributing. Here, 4 times 3x would give us 12x. And 4 times negative 5 is negative 20, plus 1, right there. And then you can combine these like terms. Negative 20 plus 1, that would be negative 19. Just like that. On this other side, we do the same thing. We can distribute. 5 times 2x, that'll give us 10x, minus 5 times 6 is 30. All right, 5 times a negative 6, that was a negative 30 there. And then we have like terms. Here we have two sets of like terms. We have 10x plus 2x, that'll give us 12x. And then we have negative 30 plus 11, that's negative 19. Okay. At this point, you can kind of stop. Notice both sides are already exactly equal to each other. This is enough to tell us that this is an identity, when both sides of the equation are equal to each other. However, if you continue, you'll see how this is actually very close to this problem here. Here, the next thing we'll do is we want to get rid of the x from one side of our equation. Subtract 12x from both sides, like this. And that way 12x minus 12x goes away, leaving us just the minus 19. And over here, normally we would combine like terms to get something like, 28x or something like that. But in this case, when you combine those like terms, you get 0. So there's nothing there. So just like in the problem above, if you continue all the way down, all of your variables disappear. And in the end, you're left with just an expression of one number equal to another number. The difference being that above, you had a statement that was false. But now, once your variable disappeared, you're left with a statement that's true. This is the case of the identity. Again, think about what this says. What you're looking for is what value can you plug in for x to make this side equal to this side? Well, when you simplify it, you realize this is always equal to that side. So in the end, if you plug it in x is equal to 4 for all the x's, this would simplify down to negative 19 equals to negative 19. If you substituted in x is equal to negative 5 to both sides of the equation, you would simplify down to negative 19 equals negative 19. Basically, because this is true down here, and it doesn't involve a variable, that means we don't care what the variable is. The variable can be anything, and this will still be true. And since when we're looking for solutions, we're looking for what numbers can we plug in to make the statement true, well, that means anything we plug in, this will still be true. So in this case, every real number is a solution. You can plug in 1 or 2 or 3 or 4. You can plug in a half, negative 1/3, any positive or negative fraction, whole number, decimal, rational, irrational. It doesn't matter. In this case, every real number is a solution. Okay? If you wanted to, you could try that. You could pick a number and plug it in for all these x's and simplify, and you'll find that both sides are still equal to each other. And pick a different number and plug it into both sides, and you'll find both sides are still equal to each other. And you can do it for any number you wanted, and it will always have both sides equal to each other. Right? So usually, when you solve a linear equation, you're going to get down to a single answer. It's going to be a conditional equation. However, your special cases, they don't appear very often, but they do happen, is when, and in the process of solving, all of your variables disappear, and you're left with a single statement that involves only constants. If that statement is false, then this equation is a contradiction, meaning there is no solution. No number will ever make this equation true. If your final statement is true, though, then you have an identity, which means that every number is a solution. You plug in any number you like, and they will all work. So that is it for this topic. If anybody has any questions, comments, problems, please make a note of those and reach out. And I hope everyone has a nice day.